Welcome to MeritHub. My name is Buddhadev Pal. I am a student of mechanical engineering. This session is very important. Those students are preparing for the SSC JE, RRB JE, and that's like of AE JE on the basis mechanical engineering. In this session, I will discuss the previous year most important questions. This is the class number 15. I have already completed 14 number of classes. Those who are not seeing this previous videos, please go through the playlist. You can watch this video. Okay, let's start. Question number 351. Okay, the differential mercury. 1 minute. I need pen. Okay, sorry for waiting. Let's start. A differential mercury manometer connected to a pipe carrying water gives a reading of 30 centimeter. What is the intensity of the pressure inside the pipe? Manometric reading, yani X is given 13 centimeter. It convert into meter, then it is the 0. Divide by 100, so 0.3 meter. We know that the pressure intensity equal to pressure X manometric reading into density of the manometric fluid by the density of the ideal fluid minus 1. So density of the manometric fluid is here the mercury is used, so 3600 divided by density of the ideal fluid water 1000. 13.6 minus 1 x into 13.6 minus 1 x 0.3 into 13.6 minus 1 into 12.6, like 6 into 3 18. 8 is the D is the answer. Last digit 8. 13.08 is the answer. Let's check the answer. Yes, you can see this process also in here. P equal to rho gh, where the h is the, sorry, I can here write the P equal to, sorry, h equal to manometric reading. X is the manometric reading, it is the h is the h is the manometric height, x is the manometric reading, into density of the manometric fluid by the density of the ideal fluid minus 1. Sorry, this is the h, not P, and the pressure intensity equal to rho gh. Next question. Let's the atmospheric pressure at the sea level 13 centimeter of the mercury. Here the mercury height is given 70 centimeter of the mercury. Convert this pressure in the terms of the water column. First it's converted in the meter 0.7 meter. In terms of meter, 1 atmospheric pressure equal to, like, this is the 76, 0.76 meter, equal to manometric height. And you can solve by this process here. Rho gh, P equal to rho gh of the mercury equal to rho gh of the water. Here the rho gauge of the mercury height is given, and this height is calculated. Rho g in the specific weight, so 13 point density 3 13600 into 9.81 into 7 and equal to rho g equal to 9810 in 9.81 into 1000 into age. If you divide by this, you can easily answer, get the answer. 9.81, this is the 10 to the 3, 10 to the 3, 1010, 10 is coming, 100, so 136 divided into 7 divided by 100, 136 into 7, 8, maybe this is the answer. Let's check the answer. Sorry, 9.5 centimeter, the 9.5 meter of the column. Here for solving this process, 70 centimeter of the mercury column equal to 13.332 meter of the column. So 1 centimeter equal 10 centimeter by the Wycliffe new. Next question. Poise is the unit of, very times repeated question. Poise is the unit of the viscosity. Next question. A different at the 2 points, so as is different in mercury level as the 10 centimeter. The difference of the pressure and the 2 points are assumption is the horizontal, and the specific gravity of the mercury is 13.6 and the fluid is pipe is 0.9 g equal to 10 meter per second. Difference of the mercury level is given 10 centimeter. Difference pressure 2 points is horizontal, specific H first minus rho g h2, a mercury and the fluid, two space of the fluid, mercury and the fluid. Here to rho g, because the height is can get the 12700 Newton per meter square or pascals. Next question. The basis of the 1 meter height of the column water will be 1 meter column of the water will be pressure 1 meter height. We know the 10.33 equal to 101325 kilopascal. Oh, sorry, just pascal. Pascal in Newton per meter square. Then you convert. We know that 1 kg if equal to 9.81. So kg into the divided by 9.81. Then unit is coming the, and meter convert meter to centimeter, then you get the answer. Let's check here. Here you can see 1 kg equal to 9.81. This is putting there. Here 9.81 is multiply, and for the kg is divided, sorry, divided here. So unit is convert kg per centimeter square. Centimeter square is. Next question, determining the value of the absolute pressure if the gauge pressure is 21 bar and the atmospheric pressure is 1.013 bar. we come to the absolute pressure equal to the gauge pressure plus atmospheric pressure. So summation of these two is 22.013 bar. Next question, friends. Pressure at a certain depth below the ocean surface is 1.4 megapascal. What is the depth of the approximate pressure in certain of the P equal to rho gh? Pressure is 1.4 megapascal. Yani 1.4 into 10 to the 6 Pascal. Rho g 9.81 into 1000 into h divided by, it is divided by this, then you can get the answer. Here the answer is 140 mm. Next question. Pressure at a depth of 15 meter, the is approximately same formula, guys. V equal to rho, and the rho g for the water is 9810 into 15. This is coming in the kilopascal. Oh, sorry, in pascal. Then which is suitable, it's convert. Then let's check. If you solve this, it is coming the 150 kilopascal. Next question, guys. Which one of the following laws you working on the principle of the Pascal's law? It is says that the pressure applied to and the enclosed fluid will be transmitted without a change in the magnitude to every point of the fluid and to the walls of the container. The pressure at any point in the fluids is the equal in the all direction. Application of the Pascal's law. Hydraulic press and the hydraulic crane. Atmospheric pressure is 1.03 kg per centimeter square, and the vapor pressure is 0.03 kg per centimeter square. So pressure air pressure is the 0.03 atmospheric pressure minus vapor pressure 0.03 or 1 kg per centimeter square. C is the answer. Atmospheric pressure is measured by the barometer. Guys, if you learn from this and it is is good for you, please like my videos. If it is helpful for you, please like. Your like is motivated to. Column manometer is useful for the measurement of dash pressure. Inclined single column manometer is used for the small pressure because it's measure the sensitivity. It is a good sensitivity. The low pressure measure can measure fluctuation. Low fluctuation can be measured by the inclined single column manometer. Next question, gauge pressure is The pressure the absolute zero. The pressure difference between its value and the local atmospheric pressure. The Earth is the below of the atmospheric pressure. The Earth is the below of the atmospheric pressure. All the above. We know the absolute pressure P absolute equal to P atmospheric plus P gauge. So P gauge equals to absolute minus P atmosphere. Absolute minus P difference between the pressure difference absolute zero. No difference लाइव इज कट गया sorry for network issue the pressure at a point in the water column 3.924 oh this is I can say here you can see the answer so pressure is 3.924 newton per centimeter square uh, according to the p equal to rho g h by this process you can solve I can told this process also be solved in this process you can solve p equal to rho gh by the hydrostatic pressure law this is for easy I think next question friends if the mercury barometer is replaced by water the height of the 2 centimeter mercury will be following the dash centimeter of the water 76 centimeter equal to mm, 76 uh, centimeter equal to in water column is 10.33 meter into 10 to the 3 10 to the 2 so 2 centimeter 1 centimeter equal to 10.3 3 into 10 to the 2 divided by 76 for 2 centimeter into multiply by 2 you can solve this you can easily get the answer let's check the answer the answer is the 27.2 centimeter this is solved by the hydrostatic law the piezometric head in a stationary or the static liquid remain constant only on the horizontal plane, increasing non-linearly with the depth below the surface, increase linearly with the depth of the below the surface. C is the answer. Increasing the linearly depth below the surface, the height decrease, depth is increases, then the pressure is increases. Piezometric head. Sorry. D. Here is the D the remains constant at the all points. Let's check the explanation. Kinetic energy of the static liquid is zero and the pressure is only the atmospheric pressure. Hence, the liquid head is piezometric head is equal to the static pressure. Pressure is equal to the every point of the liquid. All the position gives the same reading of the piezometric head. Next question. Absolute pressure in the flow system. Absolute pressure is always pressure in flow system is equal to the vacuum pressure, may be above, below, or the equal to the local atmospheric pressure. uh, I think the C is the answer. Let's check. Yes. The absolute pressure in the flow system may be more than, less than, or equal the atmospheric pressure. Flows in the pipe depends upon the pressure difference at the end of the pipe. When a vertical walls is subjected to the pressure due to the liquid on the both side, the resultant pressure is dash of the two pressures. And a vertical wall, the vertical wall, to pressure due to liquid both side, the resultant of the pressure of the two pressure is the difference. Let's check. D. Yes, difference. Next question. A micromanometer inclined tube is called micromanometer inclined tube, inverted manometer, sensitive manometer, closed tube manometer, differential manometer, micromanometer. Micromanometer is the differential manometer. Let's check. Sorry, sensitive manometer. Micromanometer is the sensitive manometer. Oh, sorry, inclined tube manometer is the sensitive manometer. क्या अब कह रहे हैं हम? Sorry friends, this is the sensitive manometer is the, micromanometer with the inclined tube is the sensitive manometer. The supply head of the pipe is 21 kilopascal for the maximum power transmission. The loss of the head due to the friction equal to, when the power pressure is given and the power equal to rho gh. Sorry, pressure equal to rho gh. And the head, what is the head? The head is the 21/10. Then the maximum power, transmission is hf equal to h by 3. Remember this, hf equal to h by 3. So you can get the 0.7 meter. Next question. The Barton tubes are generally made of the mild steel, bronze, and the nickel steel, tin, and the copper. Then the bronze and the nickel steel. The Barton tubes are generally made of the bronze and the nickel steel. Barton tube gauge is a mechanical gauge. Barton tube gauge is generally used for the measuring the high pressure. The ratio of the pressure difference of the 2 points A and B are located respective depth the below the constant level of the, water in tank. So P equal to rho G, H equal to 1 and the P equal to rho G H 2. The ratio of the pressure. So 1 divided by P rho G H 2. Rho G is cancel out. 0.5 divided by 2. 0.5 divided by 2. 1:4. Pu, you can write the P is directly proportional, inversely proportional to pressure is directly proportional. P is directly proportional to height, so P1 by P2 equal to H1 by H2. The absolute pressure in the condenser of a steam power plant is attopascal 2668 pascal. Line barometer readings is 760 mm of the mercury. Then the vacuum readings is considered condenser. Here the solid atmospheric pressure is 101 now 1013291.6 by the man. The absolute pressure 2668. The vacuum pressure is 10139.6 minus 266. So vacuum pressure P rho gh equal to, you can get the 74 centimeter of Hg. Question number 375. A mercury manometer used for the measuring the pressure difference indicate the 50 centimeter head of the Hg. The pressure difference in the meters of the meter of water. So 0.76 meter of the mercury equal to 10.33 meter of the H2O. 1 equal to 10.33 divided by 0.76 into for this 0.5. Then you can get answer. Answer is 6.8. Thank you for watching my video. If it is helpful for you, please like and subscribe my channel, and new getting new updates, please subscribe channel. Thank you for watching.